Today we're going to look at one other way to solve quadratics, and this is 9-7, and it talks about solving by square root. And there's basically two different versions or two different problem types that we're going to see, and this is the first one. And the first one, basically what we're going to do is kind of solve things like we used to, try to get x by itself essentially. So on this example, I would subtract 4 on both sides. Try to get that x squared all by itself. And we've got x squared equals 16. And this particular example works out very nicely because I do have to square root both sides. And here's where we have to be careful. Now, from now on, whenever we square root something, I'm going to move my equal sign a little bit here. We have to put in plus minus. Because when we look at our answer, sure, x could be 4. And 4 times 4 is 16. But also, negative 4 times negative 4 is 16. So we have to also take in consideration the negative value that could be a root. So remember, what we're actually solving for here is what are the zeros of this parabola? Where does it cross the x-axis? So this particular parabola crosses at negative 4 and positive 4 on the x-axis. So something like this, and this would be your negative 4 and your positive 4. So anyway, that's just a reminder of what we're actually solving for, and this is just another method. We could still use some of the different ways if we wanted to, and go those routes too. So graphing, getting 0 on one side and factoring and figuring out the zeros that way. So this is just one extra method we can use, and obviously it's going to depend on what they're presenting to us in order for us to figure out the best method. We'll be doing all square root methods on this particular video. So this one very similar. The only difference is we're going to get something that isn't quite as nice as the first one. So we get 3x squared equals 36, and then we have to divide both sides by 3. So we get x squared equals 12. And we know that this is going to have to be an irrational answer because there isn't a 12 is not one of our perfect squares like 16 was. So when we square root, we will again have to put the plus minus. And one of two things can happen here. We could write x equals square root 12 or x equals negative square root 12. But sometimes, especially if it's multiple choice, they may ask us to break this down like we had done in the past with square root. So 12, break it into 4 and 3. And we know the square root of 4 is 2. So really another possible answer here is 2 square root 3 or negative 2 square root 3. So those are probably the two that would be looked for, but again, you could also get decimals. Not again, I didn't mention that before, but you could get decimals and approximate them, or square root of 12, negative square root of 12. It just depends on what they're looking for. So one thing to point out here is this would not be a fun one to graph, because finding the x-intercepts when we have irrational numbers involved, that's something where we're going to need like a graphing calculator or something like that to help us out. So it wouldn't be fun to hand graph that one. Alright, and then the last type of example that we're going to run into, I'll do 2 of these real quick. If you have a quantity that's squared, or in this instance a binomial that is squared, we can square root right away as long as that's the only thing that's being squared and there's nothing else going on. So again, we'll want plus and minus there. And what ends up happening is your square root and your square cancel, so you're left with x minus 2 equals plus or minus, and square root of 16 is 4. So what we have to consider here is we actually have two cases. Case 1, x minus 2 equals positive 4, and case 2, x minus 2 equals negative 4. And then we just got to solve real quick. So in this instance, x could be 6. And over here, sorry, a little windy in here today. Hear my shades in the background. Good old Midwest. All right. Ooh, there we go. Yeah, having pen problems. There we go. So x could be 6 or x could be negative 2. Those would be our two possible answers right there. And again, you could plug those in and see that they work out. If you want to check your answer, you can even do it with the irrational ones. It's not that bad. But for instance, if you take 6 and plug it in, 6 minus 2 is 4, and 4 to the second is 16. And you can do that too with the negative 2. Negative 2 minus 2, that's negative 4. To the second means negative 4 times negative 4, which does give us that 16. So quick little checks you can do. And here's our last one today. I just want to show you one more of these. We can square root. And here we go, plus, minus. Oh, geez, my pen is not liking me today. Okay, so we've got x plus 2 equals plus or minus square root of 14. All right, honestly on these, when you get an irrational number, you could try breaking it down, the square root of 14. However, you're just going to run into 2 and 7. There will be no pairs or anything like that, no perfect squares. So what I would do is case 1, x plus 2 equals the square root of 14, and x plus 2 equals negative square root of 14. You could get a decimal and approximate this, but if you're looking in like a textbook or want the most accurate answer, basically how you're going to leave this is this answer, x equals square root of 14 minus 2. And you're actually just going to leave it just like that. Like I said, you could get the approximation of that, but this is the most accurate answer. You'll find out in geometry and some other classes why it's actually more beneficial to write them like this. And actually, it makes it easier. We don't have to do anything further. Looks like a weird answer, but we can leave them just like that. So again, two spots that would not be fun to graph. Trying to figure out where those cross the x-axis. But there we go. That is 9, 7.